Hey gang, the final section in chapter 6 that I feel like would be a must for us, you know, as we look to kind of prioritize and only learn like what we probably like absolutely need to learn from chapter 6. The final section that I'm going to be doing is 6-6, which is entitled which is entitled Function Operations. Function operations. So first, recall what a function is. Now I don't know if you realize this or not. I mean, like the way I realize it, but the word function is one of the biggest vocabulary terms, like in high school math. Okay, so it's one of the. I mean, I guess there's a good deal of vocabulary in math. I guess high school, but function is one of the biggies. So remember what a function actually means. It's a relation, and all that means is something involving x and y, or any two variables really, but normally x and y. A relation involving x and y, in which for every x value there is one and only one y value, meaning if you input some number for x, it can only spit back out one answer, one output, right? You input one thing, it only outputs one thing. That's a function. On a side note, most everything you see in high school, like most graphs, most equations, they are functions, but anyway. So what do we have here? Y equals 4x plus 1 is a function, so it can be written as f of x equals 4x plus 1. So I hope that's not way new to you. That shouldn't seem new to you, that we can use this function notation. Like in place of y, you can just write f of x. And so if that's what f of x is, 4x plus 1, then this would be f of 2. And now how do we find f of 2? Well, we just plug in 2. That's all that means. You just literally replace the x with 2. In other words, you plug in 2. So 4 times 2 plus 1. And then you just follow order of operations, right? That's 8, and so 9. Okay, and then just a couple more examples, very similar. Let's find f of 0. Well, that just means we're going to plug in 0. So we do 4 times 0. Now 4 times 0 is 0, plus 1 is 1. And then, of course, f of negative 3 just means we're going to plug in negative 3. So 4 times negative 3 plus 1. Well, this would be negative 12, plus 1 would be negative 11. So make sure you definitely understand this. And again, I don't think this should be new to you, that if this is what f of x is, then how to find f of 0, or f of negative 3, or f of 10, or f of whatever. You just plug it in for x. Like, okay, if I were to ask you, what's f of a? What's f of a? You would say, with 4a plus 1. You would plug in a for x. Like, you can do that. What if I said f of x plus 7? What if I put an x plus 7 right there? F of x plus 7. Well, you would plug in x plus 7 in for x, and it would say 4 times x plus 7 in a bubble plus 1. And you could, like, simplify that and stuff. But, hopefully you get my point there, that f of whatever, like you could say f of applesauce, and it would be like 4 times applesauce plus 1. Like you plug in whatever. And so here's some operations. Once again, the title is Function Operations. So we're going to quickly go through some very, very straightforward operations, like, addition, multiplication, subtraction, division, operations you've been doing since first grade, if not earlier. I mean, I don't know, maybe second grade, first grade, I don't know. But operations in math, you've been doing forever. So anyway, applying these basic operations to what we're doing now, what can I say? You can add two functions together. If you had some f function and some other function which you could call g, so f of x, and you also had g of x, you can add them together and just call it f plus g of x, which is like, okay, it's like I just said, you're just adding them together. And if you were multiplying two functions together, you could call it f times g of x, which is just f of, you multiply the two functions together. Again, this is very, very straightforward. Well, f minus g of x, you just take your f function and you subtract the g, right? It's exactly what it sounds like. And then this would be f divided by g of x, or f over g of x. That's division. You're doing the f function divided by the g function. So moving on, again, pause if you need to. Let's see this in action. So like I said, we have this f function, 2x plus 3. We have this g function, 3x minus 5. And you're supposed to find f plus g of x. Like we could write it like this. Oopsies. Like f plus g of x. Okay, but this just says find f plus g and its domain. In this time of distance learning, I'm going to, excuse you or exempt you. I'm going to exempt you from doing this, like on our homework. Okay, I'll show you the answer in all these examples, so you can feel free to look at it and think about it. But the domain I'm not going to worry about in this whole distance learning situation we're in. So the very easy notion of like, what's f plus g? You just literally add these two things together. That's it. And then you like simplify it. You combine like terms. You clear bubbles. Like, so here, I mean, I didn't even really need to put these parentheses here in the first place, because like what, we would like distribute a plus sign, which is like a plus 1. So these parentheses don't even really, they're not even necessary. And so you just kind of add the stuff together. You add the like terms together. 2x plus 3x is 5x. Positive 3 and a minus 5 make minus 2. So this is f plus g of x. And then the domain, remember the domain refers to like all of the x values, and in this situation x could be any real number, so that's the domain. But again, I'm not going to like go too deep into that. You're not really going to have to worry about the domain. Okay, now we got to find f minus g. Okay, we just do this whole thing minus this whole thing. Emphasis on we're subtracting that whole function. So here, the parentheses, like having this be a quantity, is an actual important thing, because this minus gets distributed. So it's going to be like this, 2x plus 3 minus 3x plus 5, because again, we're not just subtracting the 3x, we're subtracting the entire g function, which means we're also subtracting a minus 5. In other words, adding 5, because minus minus means adding. And then you combine the like terms, 2x minus 3x is negative 1x. Positive 3 plus 5 is positive 8. And once again, the domain, what are all the possible x values? All real numbers could be x. So now this means, of course, find f times g of x. So that's a multiplication. So this is multiplication. I just want to make that crystal clear because of what I know is going to be eventually, being in our notes here. So this is like a dot. So that means, again, multiplication. So we are multiplying these two functions together as quantities. This whole function times that whole function, which is going to involve a lot of distributing, or FOIL. Okay, like x squared times x is x cubed, x squared times 2 is 2x squared, and then we distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. And seeing as how there's no like terms to combine, we're done. And then once again, the domain, x could be anything, so all real numbers, but who cares, right? Well, you might care. I mean, I care, I guess, but how about this? F divided by g of x. So, likewise, we're just going to, just gonna divide, this divided by that, And when you have situations like this, there might be some factoring and canceling that can be done. Like you remember from chapter 8, you would not do any canceling the way this looks right here. You would first have to factor and then cancel. And so what you're left with as a final answer is x minus 2. Now, fun fact. This, considering there's a denominator, and the whole thing where you're not allowed to what? You're never allowed to what in math? You're never allowed to divide by 0. And long story short, that's why x are in our domain. Our domain is anything except x cannot equal negative 2, because that would cause us to be dividing by 0, and so that's why the domain says that. But emphasis on just f plus g, f minus g, f times g, f divided by g, stuff we've done for years. Okay. Taking a breath here because we're kind of, I guess, changing gears a little bit. This is a separate sort of topic here in this lesson, but related, composition of functions. This could be a whole brand new thing for you. So here we go. First of all, I want you to notice the symbol here. It's an open circle. That does not mean multiply. Multiply is like a dot, This is an open circle here as a symbol. I want you to notice that. And it refers to like a composition of two functions. So a composite function is formed when the output of one okay, that's, wow. Wow, that's quite a wordy textbook definition. I'll just show it to you. Because believe you me, when I think of composition of functions, when I think of composite functions, I don't think of this wordy definition. Holy crap. It's formed when the output of one function becomes the input of another. Okay, I guess that's true. But you're probably going to remember composite functions like this and how this looks. So this right here, f, this open circle symbol, then the g of x, pretty much means this. F of g of x. Like we are plugging in to the f function the entire g function. Let me just reword that slightly. We're plugging the entire g function into the f function, which is what this would describe. Okay, so let's do some examples. Couple. Okay, let f of x be this function, and g of x equals this function. So let's find f of g of x, which I always like to write it like this. I mean, that open circle symbol is nice and everything, but I think it's a much clearer picture or whatever when you write it like this. Like we're plugging the entire g function into the f function. So to elaborate a little bit, what if I asked you for f of 5? Like if I gave you this f function and said, what's f of 5? You would plug in 5 for the x's. You would say, okay, that's going to get us, that's going to be 5 squared plus 5 plus 3. And remember back here at this part where I was like making a big deal about, what if I said, like, what's f of applesauce? Well, it'd be applesauce squared plus applesauce plus 3. But here we're plugging the entire g function, which is really just x plus 2. That's not that bad. But we're taking this entire x plus 2 and we're plugging it in to the x's in the f function. We are, like, I want you to think about this word. We are replacing. We are replacing this x with x plus 2. We are replacing this x with x plus 2. Just like if I said f of 5, we would be replacing the x with 5. Replacing that x with 5. So this is what I just said. We are plugging in the entire x plus 2 in for the x's. That's all. Okay? It's really just taking these questions to the next level. It's the same thing, okay? F of 2, right? F of g of x. Okay? It's like the same thing. And so now you just got to simplify this out, like remember, this means when you square a bubble like this, it's going to oh my gosh. It's going to require FOIL. And so when you FOIL all of this, you get x squared plus 2x plus 2x plus 4, and then you get this x plus 2, which is, you can just drop the parentheses really, and then the plus 3, and so this would be your final answer for what is f of g of x. All right. One more example, like what if we wanted you to do g of f of x? Like what if we wanted to plug, like what if we wanted to do like sort of the reverse? What if we wanted to plug the entire f function into the g function? Again, this is just like doing g of 7. If I said what's g of 7, you'd say 7 plus 2, which is 9. Okay? But we're going to be doing g of f of x, right? And again, this is the open circle symbology here. Boondock Saints reference. Symbology there. I think the word you're looking for is symbolism. What is the symbolism there? If you've ever watched Boondock Saints, you know what I'm talking about. But so here's what we're doing. We're plugging the entire f function, this whole chunk of x squared plus x plus 3, into that little bitty x. Just like that. Okay? Just like you were doing g of 7. It would just be 7 plus 2. Well, boom, bam. And then you just got to clean this up a little bit. And we can do the 3 plus 2 to get 5, and we're all good. What are these boxes here? Well, on your homework, okay, you might be doing examples like this. Like g of f of 4. G of f of 4, or G open circle f of 4. Okay, G of f of 4. Now this is actually easier. So here's what I would do. What I would do is I would first find what's f of 4, because you can do that. Like f of 4 is just going to be like one final regular number. So how do we find f of 4? Well, we plug in 4 to the f function, right? So it would be 4 squared plus 4 plus 3, which is 23. So f of 4, you get 23, and now you just got to do g of 23, and so now you plug in 23, and you get 23 plus 2, and it's 25. So, you know, not so bad, right? Yeah, composite functions just mean like you're plugging an entire function into another separate function. That's all. Not that crazy. And that does it.